I'll begin by explaining the motivation for this work. The problem setup is multi-action, multi-domain dialogue policy learning. Here is a sample dialogue between a human user and a human assistant collected from the multiverse dataset. At the start of the conversation, the user asks for an expensive hotel in the north end of the town, and the assistant responds by saying that there are no results. Is there another area we can search or a different price range? The interesting thing to note here is that the system response is composed of two distinct dialogues acts, no offer and request act for the area and price lots. Allowing a sequence of dialogue acts in a single turn increases the dialogue system's expressive power. It also makes the dialogue shorter in length, which further reduces the scope of errors in the dialogues. But the downside is that the action space is exponentially larger, which makes learning dialogue policy model a much harder problem. At the end of the third turn, the user switches from the intent to book a hotel to finding a restaurant, which means a single policy model has to handle multiple domains and also maintain context across the different domains. These are the major challenges from the multi-action, multi-domain policy learning setting. And now I'm going to explain our proposed framework, which is the policy learning with interactive action selection, or PLIAS. PLIAS has three distinct phases. In the phase one, a dialogue policy is pre-trained on the human-human dataset. In our experiments, we use the multiverse dataset. In phase two, a human user interacts with the policy model in order to collect the n-best dialogues. The human user is shown the n-best multi-action output and is asked to select the best output and rate it on a scale of 1 to 5. In phase 3, we take those n-best dialogues and filter the turns with the rating of greater than or equal to 3, and then use that to fine-tune the pre-trained model. This new model is then again evaluated and compared against the pre-trained model. This is the interface that we used for data collection. The left-hand side, we display the task instructions, and then we gave the users an option of template search. This template search was used in order to control for NLU errors and so that we could evaluate the model in absence of NLU errors. Once the user selected the correct template and entered the user utterance, they were then asked to pick the assistant action for that turn. As we can see on the left-hand side, they're shown the n-best multi-action output and asked to pick one output, which is the best, and then rate it on a scale of 1 to 5. This is the architecture of a dialogue stack. It has a bunch of different components that I'll explain now. There are two different modes. The GTST mode is the ground truth slot tagger mode, where the template is directly input and we do not pass it through the NLU module. When the user is in the TST mode, they enter the freeform text, which is then passed to the strained slot tagger in order to obtain the tag slots. This is then passed to the belief state tracker in order to update the belief state, and that is passed to the action selector. The action selector in our case is the dialogue action selector policy model. The output of the model is a sequence of dialogue acts that is passed through a template-based NLG in order to get the assistant response. The DASP model is a sequence-to-sequence encoder-decoder network, and the user utterance, which is delexicalized, is input to the LSTM encoder to get the user input encoding. The belief state and the knowledge base results are both one hot encoded, and all the three encodings are passed through a feed-forward policy network and then input to the decoder. The output of the decoder is a sequence of dialogue acts, which is then again passed through the template-based NLG to get the assistant response.
To validate our n-best interactive learning approach, we used the MultiWAS 2.1 dataset, which contains about 8.4 thousand task-oriented dialogues in a variety of domains. We pre-trained a policy model on the dataset and sampled tasks from 3 domain types for n-best data collection and evaluation. We used hotel, restaurant, and hybrid hotel-restaurant tasks in our experiments. In our experiments, we evaluated 3 different model types: pre-trained models, bootstrapped models, and fine-tuned models. To get our pre-trained model, we trained a PLIAS model on the original MultiWAS dataset. After obtaining a pre-trained model, we collected n-best dialogues through our human annotators. Bootstrapped models were obtained by training new policy models on successful turns from the NBEST dialogues. Fine-tuned models were obtained by initializing model weights from the pre-trained model and running additional iterations of gradient descent over the successful turns on the NBEST dialogues. In these tables, the human row refers to ratings collected during NBEST data collection. The remaining data was collected in separate evaluation rounds. For both task success rate and average turn rating, we see a general increase in model quality moving from pre-trained to bootstrapped to fine-tuned models. Since the dialogues were rated by single annotators, we also investigated the average increase in user satisfaction rating when grouped by the annotator performing the rating. We observed the same trend as before. Pre-trained models were outperformed by bootstrapped models, and bootstrapped models were outperformed by fine-tuned models. We also investigated whether dialogues collected in one domain could improve model performance in other domains. We trained bootstrapped and fine-tuned models on data in the restaurant domain and then evaluated them across all three domains. The fine-tuned model showed improvements in the restaurant domain, as well as the hotel and multi-domain scenarios. To cap off the presentation, here are two sample dialogues we collected with the same task description. The first dialogue comes from a pre-trained model, while the second dialogue comes from a model fine-tuned using IPLIAS. In the first dialogue, the policy gets stuck in a loop asking for the hotel location. In the second dialogue, the policy learns to not ask for the location, and the task completes successfully. Thank you for listening to our presentation on multi-action dialogue policy learning with interactive human teaching.